Um, Hello, I'm Nedi Twaha and I welcome you back to another Flutter tutorial. Yeah, previously we looked at the initial basics of Flutter and how to get started with Flutter. We looked at how to set up a Flutter application, a Flutter console, and setting up the dependencies, setting up the SDKs, and also creating a new emulator using Android Studio. We looked at all that, but today we want to actually maybe review back on what we covered previously, but when we are actually starting on with code. Yeah, so initially when you create a new Flutter project, it will actually come up like this. So this is the initial code that is actually displayed to you, or the initial page. And in case you're having an emulator opened up, it will always actually open up like this. Apparently to the SDK we're using, or to the Flutter version you're actually using, this is the new display of your initial application, or your very first application when you start off with a new project. Yeah, in case you don't know how to open up an emulator on your VS Code, let's say you're using VS Code. For all the tutorials, actually going to be preferably using VS Code, but those who are actually interested in using direct Android Studio, you can actually go on with Android Studio and bring up that emulator, then later on come back to VS Code, or you use Android Studio once and for all, like use it entirely for your coding purposes. Yeah, but in case you're preferred with VS Code, then use this. Okay, so this is how your application would look like in the first place. Then you go into changing the screens and changing content according to your preference. Yeah, if you don't know how to bring up the emulator on VS Code, you come down here, you choose that, then it will display you the different devices you can be that can be actually used as emulators. Yeah, you can use this one. I already created in VS Code, sorry, in Android Studio. I showed you last time, and this is Chrome, so it's really way far better on using Chrome in your computer, whether on Mac or on Windows, because we don't have a preference for Firefox here. No, we don't have. Yeah, then we have iOS Simulator. This is for Mac users in case you have Xcode set up well. Then this is Android 13. So I created a number of emulators here, depending on the SDKs or depending on the Android versions that I really wanted, according to the different applications I was testing on them. Yeah, so you can choose one, or you can just create one, use one, once and for all, it's still fine. Yeah, so after choosing your preferred emulator, it will load up and it will be displayed here. Yeah, okay, let's continue. So initially, before you starting up with coding, I would actually like to know whether you went through programming basics. Yeah, in case you haven't, and this is your very initial time, or your very initial period of starting to code, whether it's not Flutter or any other language, I don't know, but it's really very nice to know the programming ethics, because it's what you're going to use to code. Yeah, as I said previously, programming is so way far different from coding. Yeah, so coding is just coming up with a final product using programming ethics, right, of a specific programming language you're dealing in, right? So programming basics or programming syntax is used in all languages actually. So in case you don't know how, I'll actually take this chance to take you through the different, or the various programming basics that we need to know before we go deep down into the code. Yeah, I'll explain each and every code we have here for a stateless widget, and the material app, the build widget, the override, and everything later on as we move on. Yeah, but to hint back on what we covered last time, we said with Flutter, we are using that programming language, and with Flutter, we are dealing with widgets. So it's widgets within a widget within a widget. And okay, I don't need this. I'll remove it. Okay. with Flutter, we're dealing with widgets. So it's a widget within a widget within a widget. But their main functional widgets we really put first before we actually enter another widget. So what we need in the first place, we will always need the material app, and that is actually the root widget. Okay, then within the material app, we shall call for a scaffold. Then after the scaffold, we shall call in the body, and the body can be any other widget. That's why this is body constructor calls in a container widget. So if your app you're actually interested in starting with a container widget, then inside your body within the scaffold you call for a container. Then it will depend on what you want to put it within the container, depending. Yeah. So this is another illustration that it's a material app on the topmost, then it has a home, then the home is the scaffold, right, within the material app. Then within the scaffold we have a body, and a body can be different containers or columns or rows, whatever you want. Yeah. And still another illustration is here. It's a material app that has a home constructor, right? Then the home constructor goes into calling a scaffold, right? Then the scaffold has another constructor body, then the body shall call containers, then containers can still call rows or columns or rows, or still in the body you can just bring up columns or rows. So we shall be looking at that. Then down here we have main widgets on the page. We always have stateless widget or a stateful widget. So I'll explain a stateless widget and a stateful widget. They are really different. Yeah, we have pages that actually carry static content, and we have pages that carry a dynamic content. That static content, these are actually how can I call them? Okay, this is content that is actually not changing over time, like text, like maybe that the title of maybe a container or the title of a page is not changing over time, unless otherwise if you want to be changing it over time, when you click somewhere it's actually changing. So that is not static, that is dynamic. So it's changing over time, and that makes it a stateful widget page. Yeah. So we shall go into seeing what a container comprises of padding, width, and height. We shall be looking on all that. Yeah. Okay. So initially, I wanted us to first erase this so that we see how to create this stateless widget. So I think I'll minimize this. I'll minimize this and minimize this still. And I'll delete all of this. Okay. So initially we have the import package Flutter. So in each and every page that we're actually going to be creating on our application, we shall actually need a library for Flutter stroke material.dat. So that library needs to be imported on each and every page, unless otherwise for constant pages where you're just going to be calling functions, and they don't need they don't need material.dat library, then you don't need to call them, right? But in case you need it, then you have to import it on the topmost. Then we have void main function, and this is the very main function that starts when we actually run or debug our application. Yeah, so it's the very first function that is called and within the main function we have run app. So it's a void function widget. Yeah, and I said last time that when you are dealing with a void, I don't remember whether I talked about it, but in case I didn't, let me also repeat it. For a void function, it returns nothing. It only prints what's within its curly brackets. But with a void function, it returns nothing. It doesn't have a return value, right? So it doesn't have an error where we have well, we shall see when you're creating functions that actually require a return value, right? And those that don't require a return value. So those functions that actually don't return don't require returning anything. Those we make them void. However much if we remove the void, it's still okay, right? Yeah, but it will ask for us to return something. So I'll just Control Z and I'll put back the void function. Yeah, so the function main requires a run app widget. Then we shall call for our widget my app. But my app is just a random name that is chosen. So according to the class, you're going to give your widget down here. So we shall create our class, stateless class, and that is my app. And it's returning a container. It has a widget build function for the build context. Then here we shall call in a scaffold. So I'll explain this, but I want us to first go into what we call programming fundamentals initially. Yeah, so I think I'll restart my app so that I review it. Okay. Okay, still having some errors. So oh no, so before returning a scaffold, we shall return a material app, and a material app we shall call home, as I said, then we shall call a scaffold. Okay, so I'll stop my application and run it again. For debugging, we use F5, or you can actually come here and run the debug. So I'll run my app again. Okay, so my app is up and running. Okay. So initially to bring a blank scaffold, yeah, I'll explain that, but let us first cover up programming fundamentals, because we're actually going to be needing them everywhere in our development purposes. So I'll come here and say, so I'll first put down this here, and I'll say, sorry, rogue programming fundamentals. Okay. We shall start off with variables. I think I should comment like this. Okay, these double forward slash, these are comments, but they are inline comments. These are called inline comments in case you want to comment a line, and from its start to its end, use this. And to use block line comments, I can write a number of code or syntax down here, and it's not going to be compiled in case I run my application, because these are just comments. I just want to highlight about what we're going to be studying. Yeah, so we shall cover up variables. And variables can actually be anything that they're actually going to represent, maybe functions, or they can represent a series of code, in case we don't want to actually type a lot, or we don't want to actually have a lot of code within our file. So we introduced variables to represent different syntax. Yeah, we shall be seeing that. And then we shall look at operators. Then operators. And operators, we shall look at mathematical operators or assignment operators. Assignment operators, and we shall look at these are variables. We shall look at comparison operators. Then we shall look at logical yeah, then we shall no, apparently arithmetic operators. Okay, it's just actually giving me a hint on arithmetic operators, but arithmetic operators, they're like assignment operators. Yeah, so okay. So for assignment operators, these are arithmetic operators or normal operators, or what you can call usually I call them mathematic operators. So these are the likes of addition, yeah, addition, okay, let me just addition, subtraction, division, sorry, multiplication. Okay, we all know how to use those different variables, sorry, different operators. Let's say we're adding maybe say x plus y, that is addition, x minus y minus y. So that is well known. I will not go deeply into that. Okay, then for comparison operators, here we are comparing two or more comparing two or more values or variables, right? So we shall say also equals actually goes here, have equals up there. Yeah, we are comparing two or more. Yeah, we have equals, not equal, that is greater than, that is less than, that is greater or equal. Then we have less or equal to. Yeah. So here for logical operators, we have and, we have all, we have not, well listed. Break down here. We're going to see how to use those. Okay, maybe a good example I'll give. Let's say we want to create a variable. Now let's go back here for a variable. Yeah, I said a variable can be anything. A series of code or a value can be anything that represents a series of code or a value, right? Yeah. Then okay. So let's try to create one maybe. Okay. Let's say we have a variable called let's say what example can I give? Okay. We have a variable x. So we shall declare x, that int x equals maybe 4, right? So in case we actually want to print out we shall print our x. So when I try to run, Oh, okay. The constructor is const. Okay. We'll have to remove this because we're having changing values. All right. So I'm gonna restart this. So when we try to print x, it will have here Flutter 4. If I change the value of to 120, I'll restart. So I have Flutter 120. Yeah. Okay, that's okay. So that's how to declare. We declare a variable to represent a value. So the variable x is representing a value which is an integer 120. So the int is a data type for x. So integer int is representing that whatever value x is going to carry, it should be an integer. It's not a string. And if we want to create a string, we shall say string, string name equals to Nelly, and that's a string. So in case we want to print out our string, we shall say print, then we shall call name. So when I save, I'll have sorry, yeah, I already printed out x. That's why we have 120 and we have Nelly down here. So that's how to create variables. We can create variables of integers, of strings, of a double. A double contains double variable. Let's say num. So equal, let's say something like pi, right? Maybe say 3.14. So that's a double. A double can contain whether decimal points or not decimal points. Yeah. So it is an extra, or it's an advanced way of an integer. Yeah. Then a string, just like that. So that's how we create variables. So a variable can represent anything, apparently. Yeah. So that's variables. We have covered that. So when you go to assignment operators, we can add different variables together. So I'll say, maybe if in case I want to print maybe x plus 3. So I want to print x plus 3, but x is 120. So when I save, after just saving, Control S, it will have, I'll have a value here, 123. Yeah. So 123, not 123, because I'm adding x. I'm adding 3 to x. So that is 120 plus 3, and that's 123. Yeah. So that's addition, subtraction, all the same. Doesn't matter. Yeah. So we have looked at that. I'll just erase that. I don't need to print anything. Yeah. Then for the next operators, we shall go to the comparison operators. Yeah, the comparison operators. Let's say we want to use this very first one, that is double equals. Double equals is checking whether the values equate, that is equal to. In case I didn't include it here, let me just break them down here, just like this. I want to go through this real quick. This is equal to, then this is not equal to, then this is greater that's greater than, that's less than, then this is greater or equal to. Then this is less than the opposite of the other one. Less or equal to, yeah. Then I said this is and, this is or, this is not. We shall be looking at that, but so far we are looking at comparison operators. So let's say in case I want to see whether say print let's say 2 is 2, it's like checking whether 2 is equals to 2, right? So 2 equals to 2. First of all, you should check whether the data types are the same and whether the values are also the same. So when I save, let me just save and restart. Okay, so yeah, we have true because the value 2 equates to 2, and that is so true, right? So in case I say maybe 2 is 2 equal to 8, that should give me false, right? That should give me false. So when I save and run, gives me false. This is a previous one, yeah. I just don't want to have many of them listed there. Okay, so that is false because 2 can never equate to 8. So that is comparing two values at the same time. Yeah. So this is not equal to. So in case we want to interchange this and say it's 2 not equal to 8, so we are checking the boolean of that, whether it's true or not true, right? And in our cases, this is sorry, 2 is not equal to 8, so this has to give me a true value that yes, please, it is not equal to that, which is true. So this will return a true value, right? Instead of returning a false value for 2 is 2 equal to 8, which is false down here. So in case I change here and I say 2 is not equal to 8, so this should give me a value that returns true. So I'll save. So down here it should give us true, which is so true because 2 is not equal to 8. Okay, so that is not equal. Then for greater than, that is okay. Like if I say 2 is greater than 8, that is false. So this should give us false down here. So when I try to save, it returns false. Okay, because 2 is not greater than 8. Yeah, but 2 is less than 8. Should give us true. Okay, so that's okay. We're moving faster. Then what else is required for greater or equal, less or equal? Okay, that's still the same way. Then we go into logical operators. We have and. we have and usually we use these for in most cases when we are dealing with if statements, you know, if statements or switch statements actually, or usually in loop sections. Oh, we shall be looking at loops later on, yeah. So I think I'm going to cover up this in a control flow. So let me just call this a control. A control flow, or I call these programming fundamentals. So we shall actually go into the control flow, and I'll explain how to use the and or plus likes of maybe hinting about the comparison operators. Yeah. So let's say we have, so here we shall deal with if statements. Switch. Yeah, then we shall actually go into creating functions. Then we shall actually go to data, data structures. Data structures as well, yeah. So let me explain how we deal with logic operators, and I'm going to use if statements for that. Okay, so below my comment, I'll say okay. Let me first just erase this and say for if statement to look like this. So it's asking for an identifier. So here we shall say maybe if x is if x equals to 2 or 3, okay, let's just use 3. If x equals to 3, print something. Print yes, that's true. Okay, so I'll make x as 3 up here. My variable x, I'll make it 3. So I'll run. Okay, yeah. This one I wanted. So if x equals to 3, print yes, that's true. But what if x is not equal to 3 and something else? Let's say here I have 4. What should be returned to the user, right? So that's why we call in the else function. So the else function will also carry curly brackets, and I'll have print that's incorrect. So I'll restart my application. It has to print us, that is, oh sorry, to print it's correct because we didn't change the value of x up here. So I'll make it maybe 6, right? I'll make it 6, and I'm gonna restart my application afterwards. Okay, let's restart it. Okay, which I have that's incorrect because x is not 3 up here, right? Or else, maybe if you're dealing with comparison operators, let's say if maybe x is not equal to 3, I think this should give us, yes, it's a true value because x is not equal to 3, right? Because up here we have x equals to 6 in our variable we declare up there. Yeah, so in case we have another, let's say we have another condition to check for, let me just break down. So with if statements we have if, then we have this is where we put all return output, and this is the expression or condition. If this expression or condition is true, then return our output, and our output is always down here. Yeah. Then likewise for switch statements, we shall see that. But let's first cover up this. In case we're having more than one condition to check, right? Let's say if x equals to, let's put it back. If x equals to 3, right? And let's say maybe int y equals to 4. Say int z equals to 7. Okay. So instead of just printing out one answer up here, sorry, down here, we actually going to check again. So in case your if statement is actually still running, before you close it up to the else function, we just going to say else if we call another function for if statement, else if another condition is met, another condition, let's say if y equals to 4, then print say this is the value of y. So here I'll say this is the value of x. Okay. Let's say we also still want to check out that for z, we shall say still else if and this is z equals to 7, or let's say not if z less than 7, if z is less than 7 actually, which is false, or less or equal to, or no, let's say z is less than 9, that is true, right? Yeah. Or let's say Z is greater than 5. Yeah, Z is greater than 5, which is 7. That's true. So then let's say print yes, Z is greater than 5. Okay, so this is checking for more than one condition at the same time, right? So when I save, so this is the value of y. Okay, giving me the first that equals to 3. This is false. This is true. Okay, I think let me do it this way. Let me see. Okay, if x equals to 3, give me the value of 8. Okay, then else if y equals to 4, no. Let me just try to do something quite simpler. Okay, so if x equals to 6, print correct for x, else I'll say 5. If it's not, right, it will go to something else. Else if x is less than less or x is greater than 9, print x is greater than 9. Close up here. Else if x is less than 0, which is still wrong. Okay, we're first checking x equals to 5. That is wrong, so it won't execute this. It got through this one. X is greater than 9. It is also wrong. It will not print this, so it will go into this. So it will has to print x equals or x is greater than 0 or x is less than 10, which is correct. So to print out this, x is greater than 10. Okay, yeah, it's printing out x is greater than 10 because this first expression is wrong for x equals to 5. So it went through x is equals to 5. No, it's not correct, so it won't print this. It went through another if statement. Is x greater than 9? No, x is 6, is not greater than 9, that's false, so it didn't print out this. Then it went through another one. If x is less than 10, then print x is less than 10, and which is correct, right? Yeah, and that's it. So that's how you use more if statements with if else. Okay, so we've covered that. Then for a switch statement, it's more like an if statement in case. So I'll give an example here. So I'll erase this. And if let's say we are switching, let me give int day. We're switching the value of day, right? Let me use a string this time. So I'll say a string score, right? So a string is stored in double quotation. So if the score is A, B, C, according to your score or grade, I think let me call it grade, not score. Let me call it grade. That's my variable. So I come here and say switch. The same way you use if statement, the same way you use a switch statement, though it varies in the way you write your cases. So here in a switch statement, we need an expression and we need a value for the case value, right? So an expression, we shall say we are switching grade. That's what we are switching. That's what is going to be changing over time. And for case A, we're gonna print something, right? Okay. Defining the name. Oh, I have to put it here. A. Oh, oops, am I messing up? Okay. Oops, expected an identifier. Yeah, sorry. So we are switching a value of A, right? Then we have to close up like this. Then here we have to return something. Okay, we are switching case A, and this is you scored, or okay, you scored a grade A, right? In case we have another one we want to switch, let's say case B, in case we have different cases, then after the break we shall call for another case. Let's say the case is B. Oops, I'm messing up all the time. Case is B. Then we shall print down here, print scored grade B. Okay, just like that. Then after that we shall break. We usually break so that we when after checking, we don't want this. We don't want the system to go through the if statement again. So after checking the case A and print it, we want it to stop there. We want it to have a break from there. You understand? Otherwise, it will continue to go through another one, and still it will actually print its output. Yeah. So for each and every case that you actually create, you have to break it, right? And the default value means that in case all the upper cases are not actually met true, then it actually print the default one, that invalid grade. Okay, that's a good hint. So let's say it will print for you invalid grade in case you put in maybe grade C and it doesn't exist, right? So that's what a default value does. So when we save and we restart our application, so it will print us that you scored a grade A, because the value of grade is A. You understand? So that is the value of grade A. In case we change to C, sorry, in case we change to B, it has to actually come and print us this. So I'll save and restart. Then it will say you've scored a grade B, right? So in case it is none of the provisions for the different cases you've given here, and maybe D is not inclusive here, it's a grade F. Let's say you've put in a grade F. So we save and restart. So it will say invalid grade because that's the default value in case all these upper cases are not met true. You understand? Yeah. So it's the else statement in case the previous case values are false. Yeah. But you can create a number of cases in case you want to. So I'll say maybe case C. That's a value I want to put out here. Then I'll just oops, just copy up this. I don't want to repeat it. Then I'll say this is grade C. So in case I put grade C here, save and restart. You've scored a grade C, yeah. So in case none of the above is within your case values, then it will return invalid grade, and that's a message you want to display. So that is for if statements and switch statements. So let's go ahead and look at functions. But before we look at functions, I think let us cover up loops. So with loops, we have a for loops, and we have while loops. We have also do while loops as well. We have also do while loops. Then from here, I think we shall go ahead to go to functions. Yeah. So let us first look at how for loops work. So for switch statements, let me just clear up here. For switch statements, we switch an expression. Then inside here we have a case. Then after a case we have to break, and we have a default value in case none of the cases have been made. Yeah, that's for us. Okay, so let's go ahead and look at loops. We're going to look at a for loop. A for loop. So with a for loop, we actually look at the initialization. We have an initialization. So I have an initialization, then we have a condition or the expression to be made. Then we shall have an iteration. Okay. So let's go ahead and see how this one looks like. So shall say, let's give an example for I. Okay, so for int I, initially we shall give it a value 0, right? And for I equals to 0, we have an expression. Let's say I is less than 8. Then we shall have I plus plus. Okay, we had to close this with this. Okay, so initially we initialize the value of our variable. I said for loops, we have an initialization, we have a condition to meet, then we have an iteration. So this is the format we are going to be following. We are initializing an integer, and there's a variable I, and we're initializing it to 0, just like how we initialize the x equals to 6. Yeah. Then we're saying we have a condition to meet, that I should be less than 8, right? Then we are saying we are going to be incrementing I afterwards. So we come here for assignment operators. We have an increment. This is called increment. I'll put it down. These are increments. Then we have decrements. So those actually mean, for the plus plus, it means we are incrementing I by 1. We are adding 1 to I over time. You understand? So each and every time we go through that loop, we are going to be adding the previous number. We're going to be adding 1 to each and every time. Yeah. So we shall say down here that please print the value of I now. So we shall say no. We shall say print I. So when we print I and save, we shall see that we are having from 0 up to 8 because we are incrementing the value of I. Initially we initialized I and we said the initial value, let I start from 0 and let I be less than 8. That's why we have from 0 up to 7, and we're saying we are incrementing the value of I plus 1. You understand? unless otherwise, if we want to increment the value of I to more than one value, let's say we're incrementing I to 2, so we shall say I plus equals to 2, not 3. Okay, then we shall save and run. Yeah, I wanted to remove the previous one. So we shall have 0, 2, 4, 6. Yeah, this is like print out the even numbers, right? Yeah, so this is a loop that prints out even numbers. So we initialize our I equals to 0, then we are saying I is less than 8. Yes, and we're incrementing I, we're adding 2 to I to the previous I value we printed out. So initially we print out 0, okay, then we're saying I is less than 8, and we're saying we're incrementing it to 2. So initial value of I, which is 0 plus 2, we get 2. Then that previous value of 2, we're incrementing it to 2 again, then we get 4. Then the previous value of 2, we're incrementing 2 again, we get 4, then 4 plus 2, 6 plus 2. And if you say less or equal to 8, then we shall have something like this. Just that it's repeating itself after here, but we shall have up to 8. Yeah, in case I restart over. So I'll have 0, 2, 4, 6, 8. So in case you want to increment to 4 to a 4 value and blah blah blah, that still remains the same. So that is how we do a for loop. And likewise for a while loops, literally seems the same. Yeah, actually, in case we actually to erase this or to, I'll just comment this down. And I'll say I'll call for a while loop, and a while loop we shall say while an expression or condition is met, you come up with something down here. Yeah, so I'll say when let's say I is less than 0, sorry, yeah, when maybe let's say I is less than 0, greater than 0, but I is not initialized, so we shall int I, initial value of I equals to 0, right? We have to close up this. So I'll say the initial value of I is 0, so I'll say let me give it something bigger. I want to use the decrement for the while. Yeah, when the initial value of I is 10, I is greater than 0, right? So I don't want the printed values to go past 0, right? Yeah, so I'm capping it over there. Then inside here I'll say print I. Then down here I'll say, please, I want you to decrement I. Okay, for the increment it's still the same way, but it depends on your initial values and how your condition is actually stated. Yeah, this code or syntax means that the initial value of I is 10, right? And I'm saying while I is greater than 0, right? Print I, but keep the condition that we are actually decrementing I up to the condition which is here, that I should be only greater than 0, so I is not less than 0. Yeah, that's what it means. So I'll save and restart. I need to see something down here. Okay. All right. So this is our printout. So I'll try to put this. Let me first put this aside. Okay. We have from 10 up to 1, so it's decrementing 1 starting from the initial value, right? Because I gave it an initial value of 10, then I'm saying I should not be less than 0, right? So I want the loop to stop there. Yeah, if I is below 0, please stop there, don't continue from there, right? Then decrement I, this is decreasing. In case you want to decrement I by 2, it's the same way how we did for increment, say minus equals to 2, right? Minus equals to 2, or let's say 3, okay. Minus equals to 3, and I save. So it will start from here. Leave around this is the previous one we did, but down here, this is what I'm talking about, right here. This is the last recent one. It will start from 10, 7, 4, 1, removing 3, 3. 10 minus 3, 7, 3, sorry, 7 minus 3, 4, then 4 minus 3, 1. Yeah, so this is decrementing according to the specified value you really want. Yeah. So that is the while, and likewise for the do while, you first okay, it's like let's say so we shall say do for do while our condition remains maybe I plus plus, right? No, not I plus plus. Is greater. Let's say I is less than 8. Okay, they're asking for y. So sorry, for I. So I'll initialize my I equals to 0. So I'll say do something while I is less than 8. So I want it to print I, and I want it to increment I plus plus. So I want it to print I, and I want it to be incrementing this I while this condition is met. So that is do while. So I'll save and run, because I want to remove the previous debugged content we hide. Not for confusion, actually. I don't know whether you've been noticing for a hot restart. A hot restart, that is rebuilding back your code. Then we have a hot reload that is just using Ctrl S. We shall see that when we actually go into building widgets. So this is a do while. So do while, we first do something for the curly brackets, then later we are saying while we are keeping the condition that while I is less than 8. So do print I while incrementing it, but while I is less than 8. Yeah, so that's for the do while. Yeah, that's for the do while. Okay, I'll also comment this because I don't need it in anymore. Okay, so we have looked at how to use if statements, switch statements. We have looked at loops. We have seen while, do while, and we have seen the for loops. Then we are going to go to functions now. We're going to go to functions. So we have normal simpler functions. How should I call them? Yeah, okay, and normal functions. And a normal function is given by a function, maybe name, and that's a normal function, just like an if statement. It's just like a function, but it's a switch statement function, right? Or having an expression and something to do, right? Just like how we have a void main function. This is another type of function for a void function. I think let me elaborate this here. So just like how we had a void, sorry, a void name, there's a name2, just like that. Then we have functions with parameters. Let's say oh, we already in comments. I don't know why I was putting this. Okay, put down here the structures. Functions with parameters. We have let's say we shall give a function maybe a function greet. Okay, say greet, and we have the name, maybe name. Okay, can we do something like that? Yeah. Okay, so let's just look at that. So inside here we're going to be looking at functions. Functions, and a normal function is created by let's say a function add. Yep. No, I don't want to specify. Okay, let me use name as I used up there. Function name, just like that. Did I say anything like name up here? Because yeah. I don't want it to confuse. Let me use person, name person. Okay, we just call it name person. Yeah, for name person we have something like that. Then down here we shall give it what to do, or let's say print okay, so this is a function. I think let me just create it up here. A function name, just like that, and I'm gonna remove these. I'm gonna remove these. Yep, I'm gonna remove that. Then I'll say here name person, so I'll call for name person function. If in case I want to call for that function, I call its name. So when I restart, I should see my name is Nelly, just like that, because I called it here. Okay, so this is a normal function. Then we have a void function. So for a void function, it's a function that doesn't require to return anything, right? Yeah. Then it returns nothing. but it can actually print what is within its parameters. Let's say we have a void function, greet, no, shall say greet, oh, greet, and shall print greetings. So in case I want to call it down here, I'll call name person, then I'll also bring the other one for greetings. Greet, I called it greet. The name was called greet. So I'll say my name is Nelly, greetings. Okay. So functions help us to minimize a lot of code into one variable. Yeah, so we create a variable function for each, then we call it elsewhere we want to, instead of writing this syntax of code each and everywhere we want to say my name is Nelly, in case we're going to, it's going to be dynamic and we're going to be using it preferably in many positions. Yeah, so okay, I'll save that and restart now to remove the previous debugs. And let's have a function that may be for a return type and parameters. Okay, for a function with return type and parameters, we shall have, let's say, add, say add, oops, call a function add. Then here I'm going to say I'm going to add values, right? Let's say add values a and b, int maybe b. So then inside here I'll say int c equals, okay, now I want to say sum. Yeah, I have to declare sum. Int sum equals to the value of a plus b, right? I'll just put this in brackets. So sum equals to, inside this function I'll say sum equals to a value of a plus b, right? Then I'll print sum, or I'll return the value of sum, because I want the function add to be adding those two values. So I'm restricting that the function add is requiring two parameters, right? And it's returning the sum of the two parameters. So I'm going to return sum. I don't know whether I'm clear. So inside here I'm initializing the data type for A and the data type for B. They are integers. In case they are double, you can still declare them. In case they are strings, you can still declare them. But since we can't add strings, so we're using integers. Yeah. So I'm returning the sum of A plus B, right? And that's my function. So I can use that function elsewhere in case I want to add two values, only two values, right? So that's returning that. Then in case I want to use that function, I'll just come here. Oops. I'll just come here and I'll say I'm calling for add. For add, it will ask me for the two parentheses. Sorry, no, for the two values or parameters. I need 3 or 2 and 3, right? So add 2 and 3. Okay, it's not giving me a value because I'm not printing it anywhere. Yeah, so I think it's way far good if I say print, print the value of add, then I put 2 and 3, just like that. So I'll remove this to give me 5, which is correct. And to actually get rid of writing a lot of content, a lot of code, instead of putting this inside here, I'll say, please, I need to assign the value of add to maybe say it's a int my sum. My sum equals to add 2 and 3. Then I can reuse it here. Okay, so I'll just print my sum. So here I'm just trying to minimize a lot of code, right? So if I print, I have 5 down here. If I change the value to 6, I have 8, I think, as the value. So when I restart, I have 8 instead. So just like that. Unless otherwise, that's how we can use the return for functions and maybe giving it parameters. And let's say we have parameters of string. Okay, let's say let us use an example for greeting for that greeting. Okay, let's say we have a second example for string. For strings, I'll say maybe say greet. I'll name it greet person function, and I'll specify the name of the string. So I'll give it a parameter. I'll assign it a string, and I'll say a string name is required, right? A string name, or you can give it another one, age. Let us first give it one for the start. So you say here I'll print the name, right? Let's say oh I'll say hello then plus the name variable. Let me use names. Yeah, I don't want to conflict with this variable. Or let me just comment it down, because you can't use one variable for many. Yeah, just comment it down so that it doesn't conflict with me using the name here. So the other one, I'm making it unusable. So I'm having greet person, then greet person requires a string, and I'm going to use the string here, hello plus name, just like that. Yeah, so when I come here, I need to call for, I'll remove this, I'll start it. So I'll call for greet person, so it's asking me for a string name. Greet person requires a string name, so I'll give it a string, sorry, So I'll give it a name. Name say Tuaha. Then I'll close my function. So that means grep person function is requiring one string, which is a name, and that is it. So when I save, it has to say hello Tuaha, and that's so correct. Okay, that's so correct. This is how we add another value to our string, or a string plus a string. Okay, if we are printing or if we are outputting, yeah. So you use plus, then you add whatever variable you want according to what it's stored in it. Yeah. So that's how we use strings in functions that require parameters. Yeah. So what is left for functions to maybe point out? I think that's all. Yeah, that's all. Let's try to move to something else. Looked at functions. Yeah, I've seen functions of name, of number function, avoid function that doesn't require a return, then functions that require a return, and function that require a return and a parameter. Some case. So let's go ahead and maybe cover up data structures. And data structures, we can go to lists. We shall go to sets. Yeah, then we shall go to maps. So a list is a collection of elements. It's a collection of elements. And these elements, usually call them ordered elements. Yeah. Ordered elements. Ordered elements can actually have duplicates within itself, right? But unlike for sets, it doesn't require duplicates. And let me just list here and can carry duplicates. So let's say a list can be let's say we have a list, shall have a list of maybe say numbers. So sorry, a list numbers. Shall equate to, sorry, oops, Control Z. We have 1, 2, 4, 6, 8 separated with commas. And that's a list. Okay, so a list can have duplicates. Let's say we can have 2 within it, right? Unlike for sets, if we are to give a set, this is a collection. This carries only unique elements, so we don't have duplicates within a set. Yeah, so let's say a set we have a set, let's say a set num can equate to, we use curly brackets for it. I can have 4, 5, 6, 7, 8. So it can never have duplicates. Okay. Then for maps, we actually going to also look at maps, and I think, okay, let me give an example for maps. Or we can define them as these are stored as key value in key value pairs. Actually, these store elements in key value pairs. Yeah, we shall look at an example for a map. So let's say map what? Map a map jobs, a map job details. Okay, we shall say shall have a name, sorry. And here you specify the name that editor. Then another one we shall have maybe say age, and the age should be given maybe say 23. Then we shall have what else? Let's say maybe height or position. Position, manager. Just break them down here for you to see. Whereas a map, it's having pairs of values under specific keys. Okay, so let us first go within a list. Okay, for a list it's stored like this, and for numerics we don't put quotations, unlike for string. For strings we put quotations, double quotes within. Then for an example how to declare a list, we shall say lists I'll comment it down as a title for lists. Then we just say let's say we have a list of numbers, as we said up there. A list numbers equate to, so a list is stored in square brackets, a set is stored in curly brackets. Likewise for a map. Yeah. So I shall have a list of numbers, let's say 12, 23, 6. Okay, have 12, 20, 3 and 6. That's a list of numbers. So in case we want to output a value from a list, what do? We say, sort of green and passing here, let me just remove this, then I'll say that print, we're coming from numbers, then we are specifying the index 2. So in case we want to output a value in a list, we use the index. So the index of 12 is 0, the index of 20 is 1, then the index of 3 is 2, 3, just like that. I'll set up here for a list. So 4, sorry, num4 index of 0 gives us 4. Then num index of 1 gives us 5. Then num index of 2 shall always give us a 6. Yeah. Then num index of 3 shall give us 7, 0, 1, 2, 3. Then num index of 4 shall give us 8 from this. Oh, I put them under set. Control X should be here. Control V. So this should give us 1, sorry, this should give us 2, then this should give us 4, then this should give us 6, and this should give us 8. So index 0 gives us 1. Let me just remove the last one. So 1, 2, 4, 6, 8. 1, 2, 4, 6, 8. 0, 1, 2, 3, 4. That's how we count for the index. Yeah. Likewise for the set, it's still the same way. 0, 1, 2, 3, 4. Doesn't default. So I'll go back down to the list. So with a list, I'll say, in case I want to to print numbers, to print from a list, I'll say numbers, I'm giving the index of 2. This is 0, 1, 2. So I need it to print for me 3. Okay, 0, 1, 2. 0, 1, 2. It has to print 3. So when I save, it prints for me 3. Okay, so that's the index. So if I save, print the index of 0, has to bring 12. Brings 12. In case you need to maybe say make a function that prints that, let's say a function for let's say fn numbers, a function stunning, it's printing numbers with index 4. 0, 1, 2, 3. Oh, we don't have 4. 0, 1, 2, 3. So I can return that function here, fn numbers. Pop. I can return numbers just like that. So if I remove this, it will print for me 6, because fn numbers function prints the index of 3. This is 0, 1, 2, 3. So it prints 6. Sorry. In case maybe I want to now to use a parameter to define the index that I want to print from the list, I'll say int. I'll say int index, int I. Let's say int index n. So here, instead of giving 3, I'll use n. So it will print me the index of n, and whatever you see now here, instead of having a correct function, they're asking for one parameter which is required, and the function can be called with then they ask me, we expect an n and we expect you to close here. So the n value should be saying n is an identified. Sorry. So I'll say 2. So if I give it 2, that means 2 is representing the index n. So I can use this fn numbers elsewhere because it always asks for my index I want to print from that specific list, right? Yeah. So I'll say okay, save, and it print me 3 because the second index in the list is 3, 0, 1, 2. That's the second. That's the second index within the list of numbers. Yeah. And the other thing we can do for list, we can actually restrict the data type that we're actually using within a list. So instead of saying just list numbers, we can say that my list is going to be to contain integers. So I can never use a string within numbers list, right? They're saying numbers is a type list int, so it has to only contain integer values. Likewise to a list which is having string values, in case I want to restrict, I can say a list, and I'm saying this is a list that contains strings data type. So I'll say a list, let's say dash names. A list dash names is given by that. So I need to give the first name, let's say Mark. Peter. And I give Timothy, just like that. So in case I need to fetch data from the list, I'll say down here in case I need to print. So I'll print out the names. Print dash names. So when I save, they'll print for me that list. The full list are having Mark, Peter, and Timothy. But in case I need to print out only one value, so I'll say print underscore names, but with respect to the index 2. Respect to the index 2, they'll print out Timothy because Mark carries the 0th index, then this one carries the 1st index, then this one carries the 2nd index. Okay, the index of 2. Okay, yeah, so that's what it means. In case you need to print out all, you use that, and in case you need to restrict, then you restrict using that. Yeah. So I think we shall see how to add to a list and how to delete from a list when we're actually using widgets. Yeah, to be more practical. Okay, so I'll delete this up. I'll just comment it down. So let's say we give an example for what we did for our for loop, right? So let's advance it and create a function to do that. So we create a function. You create a function that is going to output our list of numbers. Okay, I'm going to create a function number count. So I'll call it a void function. Yeah. I'll call it a void function that returns nothing. So I'll say for bring my for loop for blah blah blah, execute this. So let's say for x right? Yeah, for x equals to the initial value of 0, but we are not initializing x. Int x, oh sorry, let me use something we have not used. For int m equals to 0, right? Then we are going to go into the condition statement. So int x equals to 0 and sorry, int m equals to 0 and m is less than the number of items in the list, right? Number of items in the list we're using a list of numbers, right? So we're saying m is less than the length of the list of numbers. So we shall say the list of numbers is given with numbers dot length, close like that. Then we need to give an iteration, okay? To give an iteration, we're incrementing 1 m plus equals to 1. We can use m plus plus, has to, okay, we can use m plus plus. That is going to be very, very long. Then after that, we shall try to execute. We are printing. We're printing m. Pop. Printing m. Okay. So I'm gonna call out for my function. My function down here. I'll remove this, then I'll say I'm calling the function n number count. Pop. Okay. What have we done? One, two, three, 4. Okay, so I initialize the value of m. Yeah, okay, yeah. Initially, I initialize the value of m to equals to 0, then m less number, sorry, the length of the numbers here. The length is 4, right? 1, 2, 3, 4. That's right. The length is 4. So that's why when I was printing, I was printing the value of m according to the length within the list of numbers, 4, right? 1, 2, 3, sorry, there are 4. That's so it's incrementing from 0 to the integer that represents the length of the numbers here, because they are 1, 2, 3, 4, not the index but the number 1, 2, 3, 4. So they are 4, so it's not exceeding 4. That's why I printed this, but that's not the reason. That's not the main thing that I actually wanted. I wanted to print out the names with their respective index. So I'll call here, instead of printing just m, I'll print out the numbers. I'll print out the numbers with respect, with respect to their index, right? Their index, and m is the index, right? I'm taking m as the index. Let me see. Let's start. Okay. That one works out so well. So instead of just printing m, I'm printing the value of numbers and with respect to index. So okay, so I'm having 12, 23, and 6. Yeah, 3 and 6, and that's it. So that's how you can actually print out values using a for loop. And likewise, it's the same to a do while loop, to a while loop. So once I try to add something here, 70, if the length is increased 70, maybe say I'm adding also 50, that it has to give me it has to loop until it meets the length of the numbers in that list. So I'll save, and it will reprint starting from 12, 12, 20, 4, 6. Oh, sorry, doesn't. Let me just pause and restart. Oops. Okay, I'm having oh, okay, I just think I need to rebuild this. Yeah. So while that is rebuilding, so for sets, where did we put the sets? Here. So for sets, we said how to call for respective values. It's the same way how we use for a list, just that the difference between a set and a list is that it doesn't have duplicated values for a set, but a list can have duplicated values, right? Yeah. Then for maps, we're actually going to see an example for maps as well. Just first wait for this to build up. Is it taking long? So I suppose while it is building, so that we don't eat a lot of time. Okay, so after the rebuild, it gave us all the elements we are having. We're having 12, 23, 6, 70, 50. Yeah, so it just required a rebuild to update the list. Yep. So that is okay. Then for a set, it's still the same way. So for a set, it's still the same way. And to pull out something, then we looked at string with names. Yeah, let us cover up sets as well. So I'll remove this. I don't want to. So I'll say if I'm having a set, so I'm having a set of elements, and I'm going to restrict this set to let's say a string. I might give it a name as unique numbers. Unique numbers. Then I'll say unique values, not numbers, because I said it's a string. Unique values, let's say 3, let's say grass, let's say cup, something like that. Okay, has to be a set with a capital letter. Okay, just like a list. So in case I want to create a function that returns list of elements in a set, that is still okay. So unless if I want to bring out one element, I'll say print. So same syntax or same criteria follows. So I'll say maybe a set unique numbers, so unique values. Then I'll give it the 0th index. Oops. Okay. So unique values. So give me tree, grass, and cup. Yeah. So that's how to print elements in a set. And something else. Something else. Let's say maps. Let us also look at maps. And the other thing I wanted to say, in case we have in a set, the difference with a set with and a list, I said we don't have equal elements. So two elements in a set literal shouldn't be equal. Change or remove duplicate elements. So this value cup won't be recognized. So once you have more than one, it will only pick out one out of the many. Yeah, so that's a good thing with a set. Yeah. For list, you can have different elements of the same value. Let's say you have 50. No issue with that because it to always bring all of them. You understand? Yeah. So with the element in a set, you only have to output one at a time. So after elements, let me rush to maps. Well, you're seeing a map. And a map, we gave an example here for a map. We said this is a site. Map. Shall say map. A map. I'm going to give it maybe say yeah, just like how we called it job details. I'm going to call it my details. My details equals to that, and shall close just like here. So inside the map, I'll say name. I'll give it a value. Mark Donald. Put another one. I'll put a comma still. Then I'll give it another key. Okay, this nice age 28. I'll give it another one. Let's say height 120. Okay, just like that. That's for a map. So in case I want to output a value from a map, what do I do? So I come down here and I'll say, I come down here and I'll fetch for details. So I'll say print. Oh, I'll say print. So under user, under my details, underscore my details. I can print all of them, by the way, if I want to. I can print all of them. So they're here. Name, McDonald, age, blah, blah, blah. But if I want to only output one key, I'll say print the one for name, sorry, call for my details. Then I'll restrict the key for name, so it will only bring me McDonald. Yeah, just like that. So in case I need the same for printing age, it will be 28, just like that. Okay. So I hope this has been so good, and I hope you've actually got to understand the syntax well and the programming fundamentals. Yeah. So we have looked at programming fundamentals for using operators, variables. Then we have went through the control flow for if statements, switch statements, and we have went into loops. We have went into functions, the number of functions, and functions with parameters, void functions, functions with return values. Then we have went into data structures for lists, maps, sets. I hope it has been very, very interesting on your side, and I hope you've actually gained something. So before you go into integrating your application, we shall always need programming fundamentals, and it was very, very nice for us to go through the programming fundamentals because we're going to be using them everywhere, like a lot and a lot. So before you go into knowing what is a widget, you need to know the programming fundamentals, and this is actually helpful in different languages. Not only that, yeah, programming language, but in different programming languages, whether PHP, whether a C, whether C++, whether Java, the likes, you understand? Yeah. So I'll end here for now, and we shall actually go to another programming lesson now, how to deal with widgets and understanding more of material widgets and stateless, stateful, and explaining more of what our application is going to be and how to display content onto a screen within a scaffold. Thanks for watching.